Thank you everyone for joining us for this webinar on MQTT, what it is and why it matters, presented by Craigie. My name is Laura Lawrence and I'm the Global Director of Marketing at Harmon. Just a few things before we get started. Everyone on the call is muted. However, you can answer questions or you can ask questions in the chat function and we'll consolidate those and answer them at the end of the presentation. The webinar will be recorded and the link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control, and we'd like to encourage you to take a look at the different webinars in our Learning Sessions workshop series. You can find that on pro.harmon.com, as well as visiting Harman Professional University to see our many on-demand and certification courses that are available to you there for free. And now I'd like to introduce you to my colleague, Craigie, the presenter for today's webinar. Over his long and varied career, Ian has worked as an audio engineer on Grammy Award-winning projects, a residential AV integrator, and an independent AMX programmer. In 2016, after an 11,000-mile motorcycle trip across Europe and Asia, Ian became a technical trainer for Harman Professional University. And now I'll pass the mic over to you, Ian.
Thanks, Laura. Welcome all to this 45-minute or so examination review of just what exactly MQTT is and why we may well find it useful in our audio, video, lighting control space. That certainly is something that Harmon Professional is of concern with. We won't get too buried in the details or too deep into the weeds in terms of how exactly MQTT works. But we certainly will be taking a look at a lot of the facets of it. And then also there's a little bit of demonstration purposes here towards the end in terms of some I think some compelling use cases of the role that MQTT could play in our little industry here. So MQTT was originally an acronym for Message Queuing Telemetry Transport as it was originally introduced in the 1990s. However, at this point, really is no longer an acronym. It is just known as MQTT, and that is now simply the name of the protocol. In its most simplest consideration, it is an open standard client-server subscription-based message transport protocol. It was originally designed for constrained devices on low bandwidth, high latency, unreliable networks, while one of the earliest large-scale deployments was for monitoring various sensors in oil fields. So I'm guessing that the unreliable network in question here was running down 3 strands of rusty barbed wire in West Texas. So, and reliability is really much ingrained within MQTT to this day. Some of the key behaviors of MQTT from the original design brief that are then behind its continued utility are first off, its openness. It is an open specification. There are 40+ open source client implementations available. It is very highly deployable with a lot of interoperability available. It's lightweight. There is minimum overhead with this client as it runs at those endpoint devices. It runs in a very efficient format with regards to again within those constrained devices, and again within consideration of those constrained devices, it runs as a very tiny client. The footprint typically measured in terms of kilobytes as opposed to anything else. The reliability, probably the key defining factor of MQTT is that reliability aspect, and that the fact that QoS, quality of service, is built in, it's baked in, and it's very much the defining behavior of MQTT. And it's simple. There really are 3 basic logical components to a client: the connection, publishing, and then subscribing to data. The specification itself is all of about 43 pages. Certainly within context of other networking protocols and standards out there, that is a very simple protocol document to read through. With regards to the model itself, it's made up of clients and servers. The server in MQTT parlance is known as the broker. The clients can be either subscribers or publishers, and it's not a mutually exclusive thing in that publishers can subscribe and subscribers can publish. It's just the act of what a client can do is described as publishing or subscribing. The data values are transported around the network, referenced by a key called a topic, and then clients can publish data or consume the data via subscriptions based on that topic. So in the case of the subscribers that are interested in being informed of transitions of a parameter, the parameter would be referenced as a topic. The subscribers would basically inform the broker through a subscription that they wish to be informed of anything regarding that particular parameter based on the topic. The publisher then, as the source of that value transitioning, would inform the broker based on the referencing the topic of any time that data point transitioned. The broker then disseminates that information to all of the subscribers, again, and it's all referenced via topic. With regards to MQTT and where we actually see it most implemented these days is very much with regards to IoT, the Internet of Things. Considering the key design principles driving MQTT, that minimum network bandwidth and minimum device resource requirements, the ensuring of reliability and delivery assurance with the QoS, it's really little wonder that MQTT really has become the de facto transport of all things IoT. Current calculations are that machine-to-machine connections that support IoT applications will account for 5% of global IP traffic by next year. There are some predictions out there that in total there will be 42 billion connected IoT devices generating 80 zettabytes of data by 2025. And we can see here through this trend chart that that indeed MQTT is very much the prevalent transport of all things IoT. This was snapshotted about 10 days ago, so pretty current. And you can see that there have been points in very recent memory that MQTT accounted for 100% of the IoT traffic on the network. With regards to these other common IoT protocols that are listed up here, just really quickly, AMQP, Advanced Message Queuing Protocol, is an open standard application for message-oriented middleware. XMPP is Extensible Messaging and Presence Protocol, communication protocol for message-oriented hardware, middleware based on XML, that's the extensible part. And then finally, COAP, Constrained Application Protocol, is a specialized internet application protocol for constrained devices and is the protocol most commonly compared to MQTT for IoT developments. The two, actually all four are similar, but especially COAP and MQTT are similar, but there are some notable differences. MQTT, as designed, is a many-to-many protocol, whereas COAP is very much a one-to-one protocol for communication between server and a client. COAP does currently provide for metadata discovery and content negotiation features, which MQTT has previously not provided, but we'll see here in a few slides that that's not actually the case anymore. All of these protocols have comparable bandwidth, latency overhead, and resource requirements, but MQTT does very significantly outperform with respect to reliability and quality of service. Again, that fundamental key aspect of MQTT. With regards to the pervasiveness of MQTT traffic, and just in danger of dating myself here, to paraphrase Marge from that old dish soap commercial, we really are soaking in it. Since its introduction, MQTT has successfully connected countless numbers of constrained devices and deployments of all sizes. Popular use cases that are out there include connected cars, manufacturing systems, logistics, enterprise, chat applications, and mobile apps. Really, from your phone to your car, to your home, to your office, it very much is pervasive and all over the place. some of the known and or strongly suspected large-scale applications of where MQTT is currently being implemented: Facebook Messenger, Microsoft Azure IoT, IBM Watson, Amazon Web Services I/O are in some way or shape or form making use of and leveraging the MQTT as a transport across the network. So some of the particular features of MQTT that are compelling, especially within regards to possible role in our AVL control space, are as such. Just to note that MQTT 3.11 became an OASIS standard in 2014, Organization for the Advancement of Structured Information Standards, and then subsequently in 2016 became an ISO standard. So within version 3.1.1 of MQTT, we've got support of multiple transport protocols at its basic level, TCP sockets and WebSockets, plus then the secured variant of each of those, transport layer security and secure WebSockets. Also, UDP is supported with the MQTT-SN for sensor network variant as well. So a plethora of protocols are supported with MQTT. The data itself, the payload of the data is agnostic. The actual the payload, the value that's associated that's being transported with regard in conjunction with the key can be anything, be it binary data, textual data, XML, JSON, whatever. It really is irrelevant because the payload itself is agnostic. And while that payload is probably typically small, just note that the standard, the specification itself can support a payload as large as 256 megabytes within a single MQTT message. QoS, quality of service, again, really that defining feature of MQTT. There are 3 levels of QoS embedded within the protocol. Each message that is published can have its own unique QoS applied. There is level 0, which is defined as at most once. This is where there is very much a stable connection between sender and receiver, i.e. the client and the broker. Level 1, at least once, where there is a need to get every message to the receiver, and the application, the use case can handle duplicate messages being delivered. This is probably the most common QoS level that's deployed at that message level. And then there's level 2, which is exactly once. And this is very much for critical applications where it is required to receive all of the messages once and only once. Just note that there is additional processing and then, of course, incurred latency as these QoS levels increase. The concept of a retained message, which is, I find fairly interesting in the fact that we can leverage the server as a persistent memory repository. And we can flag a message to be stored as a retained message at the server. So the broker ends up retaining that last known value that was sent. The benefit there is that any newly subscribed clients will immediately be synchronized and receive the last known good message upon their initial subscription. With regards to the sessions, there's options for sessions. A clean session is available where after a disconnect, all of the information with regards to that session is purged, and any connection is a new connection starting from scratch. This is most appropriate for where you have a client that will be exclusively publishing data. There will be no subscriptions. The persistent session option basically allows for the broker to store all of the information about a previous session. So if with a disconnect and a reconnect, all of that previous session for the client will be immediately available. Previous subscriptions for that client can be restored. Also, with regards to messaging, all messages that the client has not yet confirmed or that were missed while offline will be propagated to that reconnecting client. And then finally, the last will and testament feature. This allows for the notifications of subscribing clients about an ungracefully disconnected publishing client. Each client can then specify its specific last will message when it connects. And then in response to an ungraceful or any ungraceful disconnection, the broker will send the last will message to all the subscribed clients. So at that subscriber application, the logic can be dealt with to deal with a publisher that is no longer present. So there's some connotation there. The subscribing clients can actually be informed about what's going on with the publisher. With regards to security and MQTT 3.1.1, first off, because of the original design brief of MQTT, security was, for lack of a better word, deliberately not sophisticated in this release. But that being said, there are some handy features within here. We have the support of standard connectivity, authorization, and authentication at the server. And not only can general access to the broker be authenticated, but we also can apply access rules at the topic level. So we can provide access restrictions based on the requested topic. The biggest challenge currently with MQTT 3.1.1 that we do see is when connecting to cloud services where there is being implemented a more modern challenge and response authentication and authorization process. Typically, this is handled externally before the MQTT session is established. So just be aware of that with regards to this particular version of MQTT. Secure connections as communications, as already been mentioned. Transport layer secure communications with the TCP sockets and WSS secure WebSockets when it comes to the WebSocket implementations. And then finally, because of that agnostic nature of the payload of the data itself, we can apply application-based tools and encrypt the data because, again, the data doesn't matter. It can be hex, it can be strings, it can be JSON, it can be markup language, it can be binary, it can be encrypted. So we actually, at the client layer, we can be encrypting and decrypting our data as required. So last year, almost pretty much to the, actually to the month of April last year, 2019, MQTT version 5 was released. And again, an OASIS standard. It is the new OASIS MQTT standard. And it is based very heavily on version 3.1.1, but it significantly updates the feature set to transition from that oil field in West Texas to this more universal IoT superhighway, which is very much its new role in life. But we do actually, but there is a minimizing of incompatibilities with those previous versions as well, which is kind of nice. So some of these key new features that we are now seeing and have access to in V5 is improved error handling. So session and message expiry values can be set so the server can be doing some garbage collection, automated cleanup with respect to unconnected clients and undeliverable message. All of my acknowledgements are now provided a reason code in the return message so that the client can be made aware of what's happening to the data even after being successfully delivered to the broker. Expanded scalability with regards to, again, with that IoT application being in mind. Shared subscriptions, which can now be used to load balance messages across a number of receivers. Message bridging allows for only a subset of local MQTT traffic at an edge broker to be forwarded to a centralized or remote broker. Interestingly, this was actually a feature that was being found in some commercial products implementations that is now being implemented, that was being implemented previously, and is now incorporated into the standard. Topic aliasing allows for the reduction of the size of the transmitted message by replacing the topic string with a small abbreviated integer value. And in consideration that the maximum allowed length of a topic string is 65 kilobytes, being able to replace that by a single integer value certainly has the potential of greatly reducing the bandwidth of the message. increased flexibility with V5. We now have the opportunity of metadata through message properties in the header of the messages. This could allow an implementation where a receiver was told which key to use for decrypting the message if multiple keys were possible, and that could just be a property that was passed along with the message within the metadata. Functional discovery now allows the server to inform connecting clients which the exact supported feature set of that instance of the broker. And then finally, enhanced security. We now have embedded within the protocol is native support for modern challenge and response authentication, including mutual authentication. This allows for simple authentication and security layer, SASL, style authentication to be used. Of course, it's supported by both the client and the server hardware, and also includes the ability for the client to re-authenticate within a connection. Embedded support now included for salted challenge response authentication, SCRAM, and Kerberos mechanisms as well. So we now don't necessarily have an external process to authenticate. It's now embedded within the protocol itself, which is a big improvement. With regards to the topics, in terms of the formatting of the messaging itself, as this data is being passed around the network, the value is associated with a key. That key is referred to as the topic. And the topic consists of one or more levels within a hierarchical tree. So when a client publishes to a topic, it's explicitly to that topic. If it's a tree, it's the slash notation with the tree. And then attached to the topic is the new value, but it's very much a single publish per parameter is required. When it comes to subscribing, absolutely the option is to explicitly subscribe to individual parameters as required. However, there's also a wildcard connotation available that can then simplify the subscription methodology. First off, we have the single layer wildcard indicated with just the plus character, and essentially it just replaces a single layer within a hierarchical tree. So in this case, what we have effected was subscription to both the level and the mute within the volume topic for room 311 on floor 3 in building 2 on campus A. That single layer doesn't necessarily have to be replaced at the end. We can replace it in the middle. So in this case, what I have effectively now done is subscribe to the modes parameter, the mode topic in all of the rooms found in floor 3 in building 2 on campus A. There is a multi-layer wildcard available through the pound character. And the net effect of the multi-layer is that when a client subscribes to a topic with the multi-level wildcard, it will receive all of the messages of a topic that begins with the pattern before the wildcard character, no matter how long or deep that topic is. So in this case, I have essentially subscribed to all of the topics found within room 311 on floor 2 in building 2 within campus A. There are also reserved topics available that have information about the server that we are connected to. They were with the $sys connotation. Broker implementations vary, so there is no necessarily standardized format of these. Best to refer to the documentation for the exact system topics enabled at each service. But just realize that there is discernible information with regards to the broker available as well, if required. From the perspective of broker deployments, there are implementations available widely: Windows, Linux, Raspberry Pi, even Mac OSs. Very much, there are as many brokers as you can imagine. Brokers also can be just as easily deployed on premises or in the cloud, and there are a plethora of cloud services out there, free ones, commercial ones, you name it, they're available. Within the standing up these brokers, we can implement a simple single entity. We can create created with or without redundancy. even within a high availability scalable cluster if required. But not only is there the opportunity of, with regards to deploying VMs or physical brokers, a possibility, but we also have the ability to deploy or to apply logical filtering and forwarding to messages between brokers based on the topic. And this message bridging allows for messages to be shared between systems, such as connecting edge MQTT brokers to a centralized or remote MQTT network. So if there was a requirement to have some shared topics between these two edge systems, we don't necessarily have to actually pass all of the data universally. We can set up through this bridging effect. We actually can only forward that small subset of shared topics across to that remote centralized broker. Or maybe there's a shared resource that's required that is, again, that centrally located client, publishing client. And again, it can be off isolated on its own. And through this bridging opportunity, we can limit the amount of traffic that actually needs to be propagated fully universally across all of the brokers. So there are a number of tools out there. Pretty much every cloud service has some sort of web console tool available. There are standalone online web tools that affect the same thing, except they're not tied down to a specific broker. There are apps available. Just check out the wiki, the tools wiki at the GitHub location for MQTT, or of course just Google up MQTT Tools. This will be the second or third option that you will find. So just a quick demo of a tool. This is the MQTT Box Chrome browser plugin. It seems to be one of the ones that I've resolved around to preferred use. I can create a library of brokers here. Of course, also being able to monitor the connection. My Raspberry Pi at the moment is disconnected, so it's showing disconnected. However, I am connected to this online broker. Within the setup for the broker itself, there's all of the parameterization that is required. So in this case, we're looking at a 311 compliant MQTT broker. The minimum requirements are, of course, the URL for the broker, the protocol of support, and here we actually have all four options available, and just realize that the topics are available universally, so I can connect through WebSockets from one application and TLS through another one. The data is interoperable at the broker itself. I also require a unique client ID for every instance of a client I connect, so that would be the other requirement. And then we have all of the other parameterization, fairly self-explanatory here, such as the clean session versus persistent session, the last will and testament if required, so on and so forth. So once I have established connectivity to a broker, I then have access to subscribing and publishing data as if I had a client. So from the perspective of the subscription, I certainly can, I don't actually know what the system topics available are at this particular broker, but I can simply subscribe to the wildcard, and now have access to every single sys topic that is supported within this particular broker instance. And we can see that immediately there's data flying around. There are, I don't know, there are probably hundreds of thousands, if not millions, of client connections to this particular broker that I'm leveraging. But the scale is immense in terms of what these brokers can support. I can test a subscription. So again, I would need to know what my topic is. I have the QoS opportunity in terms of what QoS level I want to subscribe to. I hit subscribe, and previously this particular topic had been published with a retained value. So because this is a new subscription, the first thing that happens is I am provided the last known value for that particular topic by virtue of it being retained. If I had my application, I could now run my application, and in theory, I should be able to see the data showing up as expected. I can confirm that my application from my client was publishing correctly up to the broker. I also can publish from here. So what are we at there? 65, make sure. Yeah. So again, I'll publish to the same topic that I subscribe to. I should see the loop back effect. The QoS, again, the 3 levels of QoS as available. There is a formatting type here in terms of of this particular payload. I'm just doing a JSON packet, so that's good enough. And if I publish this, my expectation is that I should see it loop around and show up. So again, I can confirm publishing and subscription from these tools. That's the basic role these tools say, and pretty much any of these MQTT tools are going to provide similar functionality with regards to vetting any application you may have written that leverages MQTT. So with regards to the libraries that are out there, this is just a small selection of them. Again, there is a curated and managed repository up in the MQTT wiki up on GitHub, where there are all access to all of the libraries for all of the languages, and there's typically more than just a single option for each of the languages that are supported. I'm pretty sure here that within this listing that we have, that there is a open source library for all of the audio video control platforms that most of us are used to, and that make use of in our day-to-day jobs. Of most interest to us here at Harman Professional is also including the fact that both of our AVL control platforms, with the languages that they support, indeed there are open source libraries for both Java and JavaScript, which is kind of handy. Just a real quick review here through the simplicity of these implementations. This is just a quick look at the PAHO MQTT JavaScript client. The PAHO implementation is pretty much the original one. I believe it's still still referencing some of the IBM early development work. But from a simplest implementation, we instance up the MQTT client. Minimum parameterization that's required is the URL, the port number, and that unique source UID that then identifies this client from any other ones. In this case, 8000 port number is the WebSocket connection. In terms of publishing up to the broker, we just very simply invoke the send method within the MQTT client object. Minimum parameterization, the topic, obviously, in this case, Harmon Live Workshop /MQTT/demo. Obviously, that is a requirement. And then the payload. And in this case, I'm passing up a JSON JavaScript object notation string of the data that I want to pass up. And then the other two parameters are the QoS level. So here I'm just referencing QoS level 0. And then the true refers to the retained parameter. Is the broker going to retain this value going forward? If I didn't want to retain it, I would set that last parameter to false. From a subscription point of view, it's just a matter of invoking the subscribe method at the client. Minimum parameterization is the topic that you wish to subscribe to, and this is where we could apply those wildcard parameters if needed. Then at that point, certainly within the context of JavaScript, a callback function needs to be implemented, this onMessageArrived method. And at that point, it's just a matter of parsing out the various components from the message itself to identify and then to react to the data, the payload, as it's returned. So interestingly enough, and just because we just took a very quick look at a JavaScript implementation, that, you know, with every modern browser being able to support WebSockets, that means any web browser can be a full-fledged MQTT client. All we need is a JavaScript library that enables MQTT over WebSockets and a broker that supports MQTT over WebSockets. I'm not going to talk too much about WebSockets at this point because I'm doing another webinar on May 15th that is all about WebSockets. But in basically WebSockets provide bidirectional communication between a browser and a web server, overcoming the restriction of initiating regular raw TCP sockets from a web browser because security. So on a network of MQTT-enabled devices, the web browser can become my control system. Each of my control devices would be subscribers to their command topics, and the browser would subscribe to the current state topics so end user feedback can be provided. When the user interacts with the web browser and requests that device state transition, the web browser would publish to that device's command topic. The device being subscribed to that command topic would receive that message that was just published, and it would transition as requested. As it transitions, it would publish to its state topic. The web browser, having subscribed to that state topic, would receive that message, and feedback would then be presented to the end user, all without any requirement of a centralized control script. All of the logic is contained within the web browser, probably as a JavaScript scripting file. The only requirement then would be some sort of server, would be an MQTT broker, and some sort of server that could serve up the web pages to that web browser device. So in terms of, you know, what I think is a very compelling use case for MQTT inside of our audio-video lighting control space is this whole concept of state synchronization and system interoperability. I am going to reference specific Harmon Professional products here just because this is real. We've actually we see these use cases out there, and we've seen these implementations being deployed. But it's very easy for any of these control systems to be replaced by any other control system brand, as long as it had the opportunity to support one of those standard libraries that's available. That again, this state synchronization and interoperability, I think, is really where MQTT can currently play a pretty important role. For those of you who may not all be that familiar with what exactly a netlink system is, Netlinks is a proprietary control scripting language here within the AMX family. It's very centralized. The UIs are essentially just passing their events, their button presses, anything that happens there. There is no logic at the UI hardware. All of the controller has that centralized management and monitoring of those events, and the code is then logically propagated. The Netlinks is a proprietary language, but we can support in parallel Java code as well. At the SCSI side, sorry, I'm getting ahead of myself. At the SCSI side, it's based on HTML, standard HTML5 and JavaScript. Each of the UIs is renders independently, HTML5 code and JavaScript code. And in its simplest consideration, the code to control the device is actually embedded on the button on the web page that's being rendered at those UIs. Important consideration is that each of those UIs is essentially a separate web page. They are very much independent systems and can be considered to be completely independent control systems from that respect. So that brings up the question is, well, how do I simply achieve state synchronization between these otherwise independent control systems? If I had two of these HTML5 user interfaces in a room, that had the concept of a mode, so presentation mode or conferencing mode. How do I enable that mode from one of these UIs and then have that propagation be information propagate up to the other UIs that could be focused within that room? Maybe these are combined and uncombined spaces. You know, again, how do I propagate the state of those logical components around the systems that are essentially independent? And, you know, what if I also then decide I wanted to leverage the legacy Netlinks control system, where I could leverage the robust nature of that controller in terms of, you know, picking as a gateway, as an interface to an asset management system or a scheduling system or some other requirement of a robust back end, which is the role that Netlinks system could play. At this point, what I'm looking at is I'm actually looking at 3 disparate and very unique standalone systems for all intents and purposes. And as it turns out, implementing an MQTT service is probably the most efficient way to do it. The HTML5, we can run the JavaScript, very easily run the JavaScript open standard client on the HTML5 clients. We can put a very lightweight wrapper around the Java open source client on the Netlinks system, and we have this interoperability available very quickly. So here's my HTML5 component that actually happens to be running up on the MQTT. I can very simply create multiple instances of this HTML5 component, and I have state synchronization all through MQTT. And heck, just because I create another one, these are, you know, these can easily be considered 3 different web browsers running on 3 different pieces of hardware, and we have that interoperability, state synchronization enabled all through MQTT. And just because I'm here, what the heck? Let's bring in an AMX control platform. And I now have interoperability. So I've got basically all 4 of these independent control systems are all being synchronized through they're actually being synchronized through a cloud MQTT broker with regards to that. It would be just as easy to do an on-prem as well. And then, yeah, just to reinforce what Laura was talking about with some of the opportunities that are available at Harman Professional University, we have hundreds, if not thousands, of hours of content available on demand. We have certification paths for all sorts of Harman branded and technologies. We also, I believe this is still the case, that we provide more Avixa CTS RU units than pretty much anybody out there. So in terms of what we actually have, we have a bunch of live classes currently in rotation. These are 1-day and full 1-day and full 2-day remote learning sessions that we're running. These are all part of the certification streams as well. And as you can see, that if you spent, about 2 weeks of your time and you managed to sit in on all of these classes, you will attain a total of 32 Avixa RUs, which is more than enough for this session, this 3-year period of renewal. So you'll be all set up going forward for your next renewal. And that's about it. I'm here to entertain questions.
We do have a few questions.
Sweet.
The first one is asking if MQTT version 5 is now available.
Yeah, it was published a year ago, April 2019. Now, caveat here, I have not done anything with it. It's on a list of things I would like to do before stuff gets back to normal, but so I can't give you any specific insight in terms of what's going on with it. But yeah, it's published, it's out there, there are implementations that are using it.
Okay, the next question is asking if they can run free VC on MQTT.
Again?
It's asking if they can run free VC on MQTT.
Not quite clear. I'm not clear on the context of that, what free VC is. If you're asking, go ahead.
There isn't any clarification, but the person who sent that question, if you want to just send an email over to Ian, I'm sure he'd be happy to answer that.
Yeah, I mean, if it's if I'm going to assume, I'm going to take a wild guess that VC refers to video conferencing, possibly. I don't know. But if the question is, can MQTT be used to transport whatever this VC thing is? Yeah, again, the package is agnostic, and with it being able to support 256 megabytes per message, yeah, you can move a lot of data around very quickly.
Okay, the next question is asking if MQTT is the control structure for the BSS BCP 555.
No, but I would certainly encourage whoever asked that question to sign up for the WebSocket seminar on May the 15th.
Okay. There's a question asking if there is a library for netlinks.
So we have a MQTT module available in Duet. It's not available or published in the database up on the website, but we can distribute it. So probably the best way to get that is to email me, and I will make sure you can get that.
All right, next question is asking which Harmon products will support MQTT out of the box and which legacy products are planned to support MQTT without writing their own MQTT lightweight wrapper.
Panel builder, so any panel builder UI, the JavaScript control product, literally without any editing, you can just bring in the, well, I have experience with, certainly with the PAHO client, so it's just bringing in the PAHO JS file, instancing up an object, and you're done. With regards to the netlink side, you would want to reach out and get a copy of the Duet module. And again, it's a very simple. It's as simple an implementation through the virtual device as what we saw in the JavaScript. That would be your best pass. It may be feasible to a certain extent support some of the functionality in MQTT within netlinks, but again, there's a module available that's probably the path of least resistance. Was there more questions there? More of that question?
Well, there's additional questions. Is there an official Cafe Duet module available?
Yeah, so we do. Yeah, so we do have a Duet module that is available that does fully support MQTT. If you are looking for if you're looking for the actual Java code, if you wanted to take a look at what the source code looked like, I have a version that I did that I can provide. However, you will need to secure the J2SE 1.8 version of Cafe Duet to look at that, because again, it is dependent upon the full standard edition of Java to run, which of course the NX processors support. But yeah, reach out to me, and if you're looking for the Java source code, I can certainly give you a version of that to look at.
Okay, the next question is asking if the N8002 and the 8012 support MQTT Broker.
Stay tuned.
Okay. Next question, encoders and decoders support MQTT client?
No, they would still, within the context of the endpoints themselves, no, they're still relying on the open API.
Next question is asking if the N command has built-in MQTT Broker and which version.
Yep. Stay tuned.
All right, in terms of implementing small room management system for few rooms in a building, what is the best platform to visualize and give statistics about room usage?
Bit off topic, but I would suggest probably the AMX RMS remote, Resource Management Suite server tool would be your best and easiest way to get that done.
Okay. The next question is asking, how does MQTT play into the future of Harman Products and the AVLD industry?
I don't have a lot of insight specifically with regards to Harman. I think it just in terms of interoperability and the fact that pretty much across the board with regards to all of the major manufacturers of control platforms, we are all supporting some sort of standards-based language that you can achieve interoperability through MQTT. I think that is, right now, I think that is, it's really strong, the role it can play really strongly. You know, we all have situations where you've got a mix of hardware platforms involved in a project through, you know, legacy systems and new phases rolling out. I think that, you know, if you can support a client on a legacy system, that deprecates the requirement of actually throwing out the baby with the bathwater and basically reinstalling everything over again. In theory, it potentially can further the life cycle or the shelf life of existing systems without necessarily having to remove them in order to deploy the new thing. Again, it's all about that system interoperability.
Okay, it looks like that was the last question that came in. If anybody has additional questions, you can feel free to reach out directly to Ian. And as he mentioned, there are some upcoming sessions that he's teaching as well as additional webinars that are on our calendar. You can find the full listing on pro.harman.com. And we'd like to thank you for attending today. And Ian, thank you for the presentation. We appreciate it.
Thank you. Have a good day,
Thanks.
all.
Have a good day, everyone.